Thank you for joining this session about monitoring solution for SQL Server. My name is Giovanni Luisotto. I work as a SQL Server DBA. I have been working with SQL Server since 2016, first as a business intelligence developer and consultant, and now as a DBA. In the last year, one of my main tasks was to find and build a monitoring solution for SQL Server. So here I am sharing what I know, what I've found so far with you. So in this session, we are going to see some common questions and needs we have when we talk about monitoring SQL Server. Then we will see what the TIG stack is, and for each one of its components, I will give you an overview, and I will show you how you can configure and run it. So let's start with some common question and needs. So the first question is, what happened last night at 1 a.m., for example? Well, maybe an ETL job failed, maybe there was an error, something was lower, in general, something went wrong, and people want to know why, and we should be able to answer that. Then another good question is the system performing as usual? Usually an application just seems slower, and the first thing they ask is the database performing as usual? Is the server okay? And so we must also know that. Then, is the server oversized or undersized? Well, this is just not about allocating resources where the resources are needed. It's also about the SQL Server licensing, because SQL Server is licensed per core. So if you can actually find an oversized server, you will save some money. And then we have how fast are my database growing? This usually happens for single application, but a more general question can be, how much storage will I need maybe for the next year when we are talking about storage planning? So our system must be able to track and troubleshoot server activities. It also must be able to perform some baselining. So we must be able to compare the current system performance with the historical system performance. Of course, it should just monitor the resource consumption on the server. And for the database growing, well, we just need to keep monitoring the database size and see how it grows in time. And now to build a system that answers, and use something called the TIG stack. So the TIG stack is a well-known set of software made of 3 different tools. The first tool is Telegraf, which is the data gathering tool. Then we have InfluxDB, which is a time series database, and we have Grafana, which is an analytic platform. So a quick overview about Telegraf. Telegraf is a plugin-driven data collector agent. It's just one standalone executable. It's extremely lightweight. It takes about 10 to 15 megabytes of RAM to run. You can configure it using some external files, and it has a great out-of-the-box value. In fact, it allows you to fetch data from over 180 different inputs, where an input can be a database system, or maybe a cloud service, or some sensors. So there is really a lot of stuff you can gather with it. Telegraf is open source, so you're free to contribute to it. If you feel brave enough, you can actually make your own version of Telegraf. And it's also completely multi-platform. So you can install it and use it on Windows, Linux, OS X, and there is also the Docker image. So you have no limits for that. Now, InfluxDB is a time series database. Time series database is a database which has been made to properly manage time series data. The case of InfluxDB is a non-relational columnar database, which is also schema-free. It features data retention and downsampling, and I will tell you later what this means. It also features a high data compression, great read and write performance, but poor update and delete performance. It can be queried using two different languages. One is called InfluxQL, which is a SQL-like language, and the other one is called Flux, which is a scripting language. You can use InfluxDB from the command line interface or using its API. There is also a graphical interface that is on a different tool. And InfluxDB is also completely multi-platform. The last part of the stack is Grafana, which is an analytic platform. Grafana features user management and security. It can also manage alert rules and notification channels. You can use Grafana from the command line, API, and graphical interface. Grafana is completely multi-platform and has a really great community. There are over 100 community-made data sources and panels and other objects you can just get from the community and use in your Grafana instance. There are also hundreds of ready-to-use dashboards for Grafana. There is a website called the Grafana Dashboard in which community members can share their own dashboards. The TIG stack is made of those three tools, but that does not mean you can't add something more. So here are just two additional tools you might want to use. The first one is called the Chronograph, and it's the graphical interface for InfluxDB. It allows you to run most of the administrative commands of InfluxDB, but to me, it's extremely handy for data exploration. In fact, you can quickly explore and build queries on your data without actually having to type the whole query. You just click around, build your query, and see what it looks like. So it's really great for that. Then we have a Capacitor. Capacitor is a data processing engine for InfluxDB. It uses his own language, which is called the TIG script, and it's a scripting language. It's an extremely powerful alerting tool and can manage and define really complex alerting rules. And it also offers several notification channels like the classic email, but also Telegram, Slack, and a lot of other notification channels. In general, I just suggest you, if the Grafana alerting is not enough for you, have a look at Capacitor. And now let's go deeper in each one of these tools. So let's start with Telegraf. As I said earlier, Telegraf is a data gathering agent, but it is a plugin-driven data gathering agent. So you actually have several plugin types at your disposal. So you have input plugins, which are used to fetch the data from the different data sources. Then you have the processor plugins, which are used to edit and apply transformation on your data. You have the aggregator plugins, which, as the name suggests, just aggregate the data you're gathering, and the output plugins, which are used to write the data somewhere else. Telegraf is configured using some external TOML files, and it's extremely easy to run as a service, even on Windows. So what the Telegraf does basically is, once you configure it, you define an interval, and every interval with the frequency you have specified, it will actually fetch the data, send them to the processor, to the aggregators, and then those data will be flashed to the output. If something goes wrong when trying to write the data to the output, the data are not lost, they are kept in a buffer, and the next time you try to flush your data to the outputs, the buffer will be sent to. So you can actually set a buffer big enough to actually keep maybe several minutes worth of data in it, and in this way compensate maybe for some network problems or something like that. Of course, once the buffer fills, you will start losing some points in it. So once the buffer fills, the oldest points will be dropped, and you will start losing some data. So here we have a Telegraf configuration sample. As I said, Telegraf uses TOM files, which is a configuration file format. As you can see, it's really easy to read. It's really easy to use. It offers several data types. Here we have a string, an integer, an array of strings. It's really simple to use, and it maps to a hash table. So it's like YAML or JSON, in which you have some key value pairs and in which the keys are unique. As you can see here, every different plugin has its own section, and each plugin can be used multiple times inside the same configuration. Exception made for the agent section, which contains the global settings. Now, once you create a configuration file, and you can create it just by going on GitHub and have a look at the documentation of the plugin you want to use, and actually copy the samples of the configuration from there. You actually have to provide it to Telegraf. So how can you provide the configuration? There are three different ways. So you have the single file, which is the easier and probably most common way to do that, which just means create one configuration file, put all the configuration data in there, and pass it to Telegraf. So you actually just run telegraf.txt --config, and then you provide the path to the configuration file, and Telegraf will run. Then there is the second method, which is my favorite, which is a single file pure plus a file folder. This tells Telegraf to scan a folder and load all the .conf file inside it. And so you can actually split the different inputs in different files. What I usually do is I have a file for the input SQL Server, for example, another file for my output. So I can actually have smaller files which are easier to manage. But there is also a single file, as you can see. Well, why? Well, turns out when they added this feature, it was not that easy to just remove the mandatory parameter of the --config. So you actually have to provide also that. And an easy fix for this is to provide just an empty file. So you can actually put all the single file in a folder and then pass an empty file to satisfy this mandatory parameter. The last method is to use an URL. In fact, Telegraf can fetch its request, its configuration from an URL to an HTTP GET request. This is really, really useful if you have lots of hosts in your environment. Every host runs Telegraf, and you don't want to get crazy connecting to each host and changing the configuration file. So you can actually put your configuration files somewhere and make them available through an URL. How to run Telegraf as a service? Well, it's extremely easy because Telegraf can register itself as a service on Windows. It allows you to do some basic service configuration. So you can just register and then register Telegraf as a service. And if you want, you can specify a name and a display name for the service. You can also stop the service, but you just use the service panel for that usually. So the command is extremely simple, and you just need to provide the -install flag when you run the Telegraf command. Just remember to use the full path to the configuration file, otherwise the service won't be able to start. And you can also, as I said, provide us a name for the service. That's useful when you have multiple instances of Telegraf running on the same host, because each service must have a unique name. So you actually have to provide a different name for each Telegraf service. Now let's see something about the SQL Server plugin. So the SQL Server plugin supports all the SQL Server Engine edition, so you can use it to fetch data from the Azure SQL DB, Azure Managed Instance, and from SQL Server from 2008 SP3 and any newer version. You can use Windows and SQL authentication, and in general, it just collects some meaningful metrics like the performance counters, wait stats, database I/O, CPU, and more like the exec request. This is what the configuration looks like. So you have the only mandatory section is the server parameter, which is just an array of connection strings. So you can actually, with this input, you can monitor several SQL Server instances at once. There are lots of different parameters available for those connection strings, but I won't list them all because I don't have the time to do that. But you can just have a look at the documentation to see which parameter you might actually need to connect to your SQL Server instance. Then you have the query version, which specifies which version of the plugin you want to use. Just stick with version 2 because the version 1 has been deprecated a long time ago. You then have the include and exclude query list, which are two arrays in which you can specify in an explicit way which query you want to run and which you want to exclude. So there are 9 possible queries as of now. So you have performance counter, wait stats categorize, database I/O, and more. You can just specify those inside of those lists, and you will run just the queries you need. And the last parameter is this Azure DB, which is just a flag with true or false. And when you enable it, there are some queries regarding Azure SQL DB will be added to your collection. Something about authentication and permission. As I said, you can use the SQL Server authentication, and to do so, you need to specify user and password inside the connection string. So you have to specify those two parameters, which are user ID and password, inside the connection string as clear text. And the best you can do to hide that is use an environment variables. In fact, you can use environment variables inside the TOML configuration file. But what I suggest you is to use the Windows authentication when possible, because you won't have any credential in clear text, and it also won't require an additional parameter in your connection strings. In fact, the user that is running Telegraf will also be used to log in SQL Server. You might, of course, need to assign it some more permissions. For example, if you are writing the Telegraf log to a file, you have to provide this user also the permission to write that file, but that's usually not a problem. And about the permission required on SQL Server to run this input plugin, to run Telegraf, you just need to provide the view server state and view any definition permission. So true harmless permission, and it's safe to use.
Giovanni, you have a couple questions.
Okay.
So the first one is, which ports are required to be open between Telegraf and SQL Server?
You just need to, SQL Server must be reachable from the host in which Telegraf is running, and that's it. Okay.
And then the second question is, can you easily leverage existing checks defined? For example, Brent Ozar's SP Blitz or DBA checks?
It depends, because you can actually edit the plugin to add your own query, or you can run some inputs that allow you to, for example, run the DBA checks. So you can actually set up DBA checks, serialize the data in a format suitable for Telegraf, and then using an input plugin called exec, which allows you to run an executable and get data from there. So yes, you can do that. If it is in, not always. That depends.
Okay, cool. Thanks.
Okay, so now we have something about errors and fixes. So there are no blocking issues or server issues as of now, but there are two errors that can actually slow or stop your data gathering process. And I want to show you how to fix those. So the first one is this is an error regarding to InfluxDB max key length exceeded, and the other one is a warning input SQL Server did not complete within its interval. So I will show you what caused this and how to fix them. So the first one about the InfluxDB max key length exceeded when writing the points. The reason is that in a query, which is the SQL request query, there is the statement text. So the actual query you're running, the text of the query, which can be huge. This data is kept is saved as a tag. This is a type of column in InfluxDB, which is part of the key, and the key has a limit. So if you keep this data if this string is too big, the query will exceed its maximum limit. What happens is that the single point will be lost, but the whole batch, which maybe it's like 1,000 different points, 2,000, 5,000 points, won't be written to the database and will be sent to the buffer. The point is that if you keep fetching queries that are too big to be sent to InfluxDB, no batch of data will be actually written. All the data will be sent to the buffer, and once the buffer fills, you will actually start losing data. To fix this, you just need to convert this statement text from a tag to a field, which is another type of column in InfluxDB, which is not part of the key. This also will make the statement text actually readable, because when it is saved as a tag, it will be just a huge one-line string with every special character, like the carriage return encoded as /n or something like that. So it's really unreadable in that way. And to fix that, you just need to provide this, which is a processor plugin which converts a tag to a string field. The other error, which is input if SQL Server did not complete within its interval. Well, this means then one of the instances we are monitoring didn't connect within the interval we have specified, and can be caused, of course, by network problems. The problem is that the whole input SQL Server session will fail. It's easier to explain it as an example. So let's say I am actually monitoring several SQL Server instances within one session of the SQL Server plugin. If one of those does not connect in maybe 15 seconds, which is the good interval for this type of data gathering, all the data I have gathered in this session will be lost. So I'm monitoring 5 instances, 4 connect and get the data, 1 fails to connect, and I lose all the data from all the 5 instances. And to fix that, I can just specify the connection timeout parameter inside the connection string. What happens if I do so is that once the timeout is reached, an error is raised for the timeout connection, and that's it. All the other data will be sent to the processor and aggregators and to the outputs, and I will lose less data. And that's it for Telegraf. Any other question?
Yes. Is it useful to have, sorry, is it useful to use Telegraf to monitor network problems? For example, understand when there was a network timeout. I'm not going to assume anything. That's the question.
You can do that. There are other input plugins that allows you to actually monitor the host itself. So you can monitor your Windows or Linux host or whatever the operating system you're using. So yes, you can do that. But if you have some problems actually writing those data, you will have a delay for that. Probably because from the machine itself, you won't be able to send the data.
Yep. Okay, good. No other questions right now, so you're good.
Now let's say something about InfluxDB. So InfluxDB is our database, and when you download it, you will actually find several executables and a sample configuration file. You just need two executables, which are the influx.x, which is the command line interface, and the influxd.x, which is the actual database executable. And you just need that. You don't need. You can also just run the influxd.x as is, and you will have an InfluxDB instance up and running, which will use its default configuration. The default configuration of InfluxDB will create the database files inside the current user folder. So in my case, it is C user Luisotto.influxdb. The database authentication will be disabled. The logs will be written to the standard output, and the port used by the database is 8086. You can also provide an explicit configuration file, of course, and I suggest you do so. But you can also configure InfluxDB just by using environment variables. You can actually configure it using properly named environment variables. And that will be the first thing InfluxDB looks for when you run it. Then it will look in the configuration file you provide, and for any other parameter, it will use its the internal default configuration. How to run InfluxDB as a service? InfluxDB cannot register itself as a service on Windows, so you have to use something else. I suggest you use on Windows the NSSM, which you might already know. For those of you who don't know what it is, it's NSSM is the non-sucking service manager. It's a really simple executable that allows you to register commands and executables as services on Windows. And it can be used from the command line and also offers a minimal user interface. And it allows you to have extremely advanced service configuration. It can also manage the input-output redirection and also file rotation. So it's really easy to manage the logging of InfluxDB using that. And just an important note, of course, you are registering a service, so you want to run it as an administrator. And as said for Telegraf, if you specify some path inside, for example, when you provide the path to the configuration file, always use absolute path. Otherwise, once you start the service, you will get some error because the system won't be able to locate the file correctly. And to run it, it's extremely easy. You just need to run nssm.x install. This will start its graphical interface, and from there, you can set up your own service. It's extremely easy, and you can find documentation online about how to do it. Now let's see a quick comparison about InfluxDB and the SQL databases. So you have the database, and the concept here is exactly the same. Then InfluxDB has an object called the retention policy, which has no equivalent in SQL databases. You have the measurement, which is the equivalent of a table. The point is the equivalent of a row, and then you have two different types of columns. You have tags and fields. So a tag can be seen as an indexed column, while a field can be seen as an indexed column. Here is what a point looks like. So a point has a measurement, which of course its namespace, it's the container of the point, it's the table of the point. Then you have the tag set, which is a set of key value pairs. It is used to provide the context for the point. You have the field set, which provides the actual values, and you have the timestamp, because we are talking about time series data. So every point has its own timestamp. In this case, an example is the SQL Server CPU measurement. As you can see here, we have the host and the SQL instance as tags. Those provide the context for the data, and the actual data is the other process CPU and the SQL Server process CPU. And then the last part is the timestamp. Now, just how can I identify a single point? Well, the key of a single point is made of the measurement name, of the tag set, meaning keys and values of the tags, from the name of the field key, and the timestamp. So almost every part of the point make its part of its key. Now let's see something about data retention and downsampling. So as I said earlier, there is an object called retention policy. This is an object that is used to manage data retention, but not strictly that. In fact, our retention policies manages the actual retention period for the data, the replication of those data, and the shard side. So the period, here is how you create a retention policy. So you have a duration, which is the actual data retention period of those data. So after 1 week, those points will be dropped, will be deleted. Then we have the replication, which is useful only in multi-node environments, which are not supported in the open source version of the software. But if you have a multi-node environment, you can actually replicate those points on several nodes. And then there is the shard side. This is an advanced settings and is usually set automatically by the duration you have chosen for the retention policy. A database can have several retention policies, and of course the name of the retention policy must be unique inside the database. Now something about data downsampling. The data downsampling is a process in which you keep high precision data for a limited time and aggregate those data for long-term usage. So for example, I fetch data every 10 seconds, okay, for my real-time monitoring. So I have a really high detail on my data. But is it useful to have the, I don't know, the SQL Server CPU process every 10 seconds after a month? Well, I don't think so. So to reduce the size of my data and also make them easier to query, because it will take a lot less time if I have less data, I can keep those high precision data for a limited time, let's say 1 week or 2 weeks, then pick this data and aggregate them in a lower precision interval. So for example, 1 point every 5 minutes, and store them in a different retention policy. Of course, this requires multiple retention policies, and in InfluxDB, this is achieved using an object called continuous query. Now, this is what a continuous query looks like. You can see it as a job in SQL Server if you want. It's just a scheduled query, a recurring query that aggregates the data and store them somewhere else. This is InfluxQL. So okay.
Hang on 1 second. I don't know if everybody lost you for a second or just me. So I haven't seen comments.
No, okay. I don't know. Everything stopped for like a second, but okay.
Okay.
So as you can see, this is InfluxQL. It's really similar to the standard SQL syntax. So you have create, select, into, from, group by. So those words sound quite familiar. And what happens here is that I create a continuous query on a specific database, and then I just have a standard InfluxQL statement, which fetches some data from the Quantum Datis Demo database from the standard retention policy and the SQL Server CPU measurement. It computes, it calculates the average SQL Server process CPU and groups those data in 5 minutes intervals. And all here means just to keep all the tags. Then those data are stored in a different retention, in the same database, in a different retention policy which is called long in this case, and in a measurement which has a different name. How often does it run? Well, this one will run with the frequency defined in the group by statement, and will fetch an interval of data which is the same defined in the group by statement. So in this case, every 5 minutes, I will get the last 5 minutes of data and group them in a 5-minute interval and store them somewhere else. You can also specify a different interval using the advanced syntax for the continuous queries. So you can just use this. So you can actually, if you want, you can create a query that runs every 30 minutes, get the last 2 hours of data and aggregate them in 5-minute intervals, and then store those in the retention point and into your long-term retention policy. The last part about InfluxDB, which is an overview about its security. So in InfluxDB, well, by default, authentication is disabled, but if you decide to enable it, here is what you can do. There are just 2 types of users in InfluxDB and a total of 3 permissions. So you have administrator user, which have read and write on every database of the instance, can use every management command, so create, alter, drop of any object, continuous query, retention policy, databases, measurements, everything. And to create a user, you just use the command create user with password. And if this is an admin, you just specify with all privileges. So this is what tells InfluxDB that this is an administrator user. For the non-administrator user, it's a bit different because their permission is per single database. So you actually have to create each user, and then you have to provide the permission on the database. So you have to create a user with password, and then you have to grant the specific permission to the user. There are just 2 permissions, which are read and write. You can also specify all, which just mean both read and write. And that's it for the overview of InfluxDB. Do we have some questions?
We have a bigger question, which I think I'm going to wait for a little bit till you're finished with Grafana.
Okay. So now, something about Grafana. Grafana for Windows can be installed in 2 different ways. So you can actually use the zip file they provide you and configure and install it yourself, or you can just use an MSI installer, which is recommended by them, but is also recommended by me. And what it does basically is to extract the Grafana files in a specific folder and register Grafana as a service using an SSM. Once you install Grafana in this way, Grafana is already ready to use. So you just need to connect to the port 3000 of the server and log in using the admin user with password admin, and that's it. You can already start using Grafana. Of course, you might want to see how Grafana is configured and change some configuration. To do that, you just have to locate the default ini file in the Grafana folder and have a look at the configuration of that file. But don't change that. If you want to provide and override its configuration, use the custom ini file. So create a new file, which is called custom ini, in which you specify your own configuration, and that will override the default ini file. Or better, it will have a precedence over the default ini file. Here we have an overview of the Grafana structure. So at the server level of Grafana, we just have 2 different objects. We have users and organizations. Most of the time, you will just work inside an organization. In fact, inside an organization, it's what contains most of the objects. So inside an organization, you actually have the data sources, the folders, dashboards, user, teams, and roles for Grafana. Roles exist and cannot be changed, are a fixed object if you want, and all the rest has to be created by you. So you have the data sources and the dashboard. Just a quick overview about security. So on Grafana, you create every user at a server level, and then this user is mapped to one or more organization. A user can also be a Grafana administrator. What a Grafana administrator can do is manage users and organization, meaning create users, map them to organization, and to create organization and set some preference on the organization. But an administrator user cannot manage the object inside the organization. So as an Grafana admin, you cannot create data sources or view reports or anything else that's inside the organization. At organization level, instead, you have three different permission types. So you have admin, edit, and view. Each one has a linked role. And those three permissions can be set on those objects. So you can specify those permissions on folders, dashboards, and data sources. Though data source, the data source permission level can be specified only on Grafana Enterprise, so you can't do that with the open source version. And those permissions can be assigned to roles, which is the default behavior. When you create an object, you will see that you have the three roles already mapped inside of the object, each one with its default permission. But you can also specify teams or single users and give them maybe the admin or view permission on the dashboard or the folder. Now here we have some quick features on the true main object of Grafana. So the main object in Grafana are the dashboards, of course, because what you want to do is to show the data. So the dashboards are saved in JSON format. The JSON definition of the dashboard can be actually viewed and edited as a JSON file. And the dashboards are versioned in an internal repository of Grafana, so you can actually roll back to any previous version. By default, I think it keeps like 20 different versions of the dashboard. The dashboard can be exported as JSON file and can also be imported from JSON file, from just some JSON text, or from the Grafana dashboard website, which is where the community shares his own dashboard. A dashboard can use multiple data sources. So if you are actually using maybe 4 different InfluxDB database and a SQL Server database in Grafana, you can actually fetch data from any of those data sources inside of the same dashboard. Each dashboard can have his own parameters and other settings, and it also features the automatic time zone conversion. So regardless of the underlying data, the user will always see the data in its own time zone, which is really useful. Then something about panels. The panels are the actual visual and charts you have in Grafana. Some panels support multiple queries and sources, so you can actually fetch some data from different databases and different data sources inside the same chart. Grafana helps you building the query in a guided way, so you actually have drop-down menus, which, for example, in InfluxDB allows you, once you specify the connection, allows you to see the list of the measurements available, of the retention policies available, and of the single fields and tags that you can use. Or you can just manually type in your query. Of course, each object has a JSON definition, and you can just view it and edit it and copy paste it around if you want. Grafana also offers a really good unit of time, unit of measure management. That means that if I have a value which is in, let's say, millisecond, I can tell Grafana, okay, Grafana, this value is in millisecond, and when I have a huge value, thousands of milliseconds, it will actually show it as seconds or minutes or hours without doing nothing more. You just tell, this is in millisecond, manage it as it makes sense, and it will manage it in a proper way. You have a really wide formatting option. You can set you can set a threshold on your chart. You can set the background color, sometimes the color of of strings based on different threshold. You have a really wide set of formatting options for the visuals. If the visuals provided by default in Grafana are not enough for your requirements, you can have a look at the community. In fact, there are over 100 panels made by community member, which you can just download and install your Grafana instance to maybe make a map or some other fancy visual. And well, this is just a warning. Some features or functions are data source dependent. So for example, if I query SQL Server from Grafana and InfluxDB, there is difference between those two, and also the features available in the panels might differ. Now I have a demo on Grafana, but first, if you have any question, that seems a good moment to me.
Yep. So have you tried using InfluxDB and Grafana on Docker?
No.
Okay. That's good, because the next question was, do you recommend it? And I'm going to say at this moment, you don't have an opinion one way or another, probably.
Well, I know there are Docker image of both. So you can just get the Docker image and set the environment variables for the Docker image. But I'm not an expert of Docker, and I don't really know how to manage to properly manage it. So I stick with system I know how to manage. And that's my point. So if you know how to use Docker properly, just go for it. It works.
Okay. And then how well does Grafana scale? So if you wanted to monitor 400 instances, would it handle that number of instances okay?
Well, that's more about, not strictly about Grafana to me. To me, it's more something related to the database you're using, because can Grafana query, that's up to how you write the query itself. So for example, if you have 400 SQL Server instances in a single database, but you actually filter the SQL instances and just get one instance at a time in your dashboard, there should be no problem at all. If you actually fetch a huge, if I query Grafana, if I query InfluxDB for the data of just one instance, but I query maybe 2 years worth of data, well, that actually puts some pressure on the InfluxDB database. So Grafana directly queries the database, the data source it has behind it. So to me, the performance problem is not strictly related to Grafana, it's more related to the underlying databases and data sources.
Okay, good. You're good.
Okay. So, okay, here I have, let's refresh this, my Grafana dashboard. So here I have, let me just hide this so I can actually see all. Here I have a set of dashboards. So here I see, let's try to answer some of the questions I had at the beginning of the session. So let's say something was wrong at 1 a.m. yesterday. How can I have a look at that? So here I have a global overview of my instances. Here I have a different dashboard in which I just have a look at each single instance. Here, as you can see, I'm filtering just 1 hour of data, but I can actually have a look at the last 24 hours of data, have a look at around, let's say, 1 a.m., which is more or less here, and have a look about how things were at that time. I can just grab this, and here I have, I've filtered this time section. I can see what was going on at 1 a.m. All looks in order to me in this case. With the data I get from the SQL Server input plugin, I can also see which queries were running on the server. So I can have a look here and see that there was this one running. I go there, I see who was running it, well, what the query hash is, the database, the actual SQL statement text, and some query performance. So this is some quick metrics about this query. Now I can go back here, and let's say I want to see how was it behaving. If the system is behaving in a normal way right now, I can just go here and fetch the last 30 days of data. And what I see is that now, well, more or less it is behaving as the usual. I can see that it collapsed somehow here, but otherwise everything is just fine. So it's really, really easy to just filter different times. You can also specify, as you can see here, there is a calendar, so you can specify a specific from and to. So for example, let's say I want the last 2 days of data, but also I can specify this interval, change the time, change whatever I want, and filter this specific interval, and just apply the time range, and that's it. Then I have lots of other metrics here. Well, let me just filter the last 1 hour. Otherwise, there are really a lot of data behind this, so it might be a bit slow. And here I have transaction, page life expectancy, something about the database size monitoring. Here I can monitor the single database growth. So here I have the size of my data files, how much free space I have on my disks, and I can also just choose one database and see how it is growing in time. Of course, you can also build a specific dashboard to have some specific insights in this. So here I have, where is it? Capacity planning dashboard that allows me to actually see how much my data are growing. So I can have a look at the data file size. I can calculate how much my data are growing in time. So I see that in the last 30 days, I've calculated that my data grew of 12 gigabytes, and on average, they grow of 400 megabytes a day. So what I can do is answer the questions like how much storage will I need for this instance in the next year, and based on that, if in 30 days I get 12 gigabytes of data, well, then just multiply it by 12, and that's it. That's the answer. Now I want to show you just some Grafana features, like the security one I talked about earlier. As you can see here, this is the permission on the single dashboard. So by default, as you can see, those permissions get assigned. So you have the admin role, the editor, and viewer role, each one with its a related permission, but you can actually change it and give the editor just the view permission, or you can add other permission to, as you can see here, use single user or teams, and give them a specific, for example, here I can get my user and specify which permission I want for this single dashboard or for the whole for the whole folder. A folder is just a container of dashboards. What else can I do? I can, I can show you what a query looks like. So here I have this visual. What it does, it runs this query. This is how querying a data source in Grafana looks like. So I have this section in which Grafana helps me actually querying my data. So here is the list of all the available measurements. as you can see, I have all the SQL Server related measurement, which is the equivalent of a table. And here I can select my actual values. So here I have the SQL Server process CPU, but as you can see, it can also list all the other fields available. So you don't actually have to learn InfluxQL to be able to query your data, even if I suggest it, because for some advanced queries, you will require it. You can't just create queries. So some complex queries cannot be made using this interface, and you will actually have to write InfluxQL code. About visualization, as you can see here, I can actually set some colors. Where is it? Here it is. In this case, I have set some threshold. And so for example, in this case, if the SQL Server CPU is over 80, the color will be red. If it's over 35, it will be orange. Otherwise, that's green. So you have a really wide formatting options.
Speaking of visualization, is there a connector in Power BI for Influx?
I don't think so.
Okay.
I'm not sure, but to me, it's not that easy to manage this kind of data in Power BI, though there are some questions about it on Stack Overflow, and you can just use the API if you are able to actually obtain a static query or something like that you want to run in Influx. So you can do it.
Okay. And then when you were looking at the security, there was a question of if you can add a user, like is there a user management?
Yeah, of course. So in this case, let me switch to the server admin section. As you can see here, I have all the users on this instance of Grafana. I can actually create a new one, as you can see. As a Grafana admin, I can create user, create organization, have a look at the Grafana settings in general. And what I can do for each user is go in and actually edit its properties, delete or disable the user, make the user a Grafana admin, and add this user to other organizations. So this is my standard user, and I can add it, and it is a viewer on those two organizations. At organization level, this is the organization level configuration. You have data sources. So here I have my connection to InfluxDB, which looks like this. Here you have just to provide the database, the user you want to use to connect to InfluxDB, because I use authentication. And then you provide the username and password, which gets encrypted inside Grafana. Then you also have the user, and you can actually set the permission for those user on those organizations. As you can see, I have an admin user, which is admin. You have the teams, which I'm not using, but those are just group of users, so you can see them as a group or just a group of users to easily manage permissions. And the plugin section here, you have the list of all the data sources, as you can see, and the panels currently available in my Grafana instance. And of course, you can as you can see, find more on grafana.com. So you can actually install new plugins. Another thing I want to show you, because this is really nice, is that you can actually have a look at the JSON model of your dashboard. Here you have the versioning system of the dashboard itself. And to export it, because this is quite useful, you have the share feature, which allows you to create a link to the dashboard and share it so people can actually see the same thing you are looking at right now. So you don't actually need to tell them, no, filter this precise time, and with this instance, you can just provide a link, and that will filter the dashboard. You can, of course, export it, as you can see, as a JSON file, and to import it, it's extremely easy. You just have to go in this section, which allows you to manage dashboard. You can import it, and here you have 3 possible ways. You can upload a JSON file, which maybe you have previously exported. You can provide an URL already for the Grafana dashboard website, or paste the JSON itself. So, for example, if I want to import this one, here, this was the dashboard number 9386, which is about SQL Server. I can just provide the data ID, and here I have the name of the dashboard, in which folder I want to place it, which data source I want to use, and then you have the ID of the dashboard, and that's it. I can just import it, and I've just imported a dashboard, and it more or less works. Here I'm missing the pie chart plugin, but as you can see, I have a dashboard up and running, and I just provided an ID to get that. So this is more or less what Grafana allows you to do.
So I have another question. Is it possible to run parts of this stack as portable applications? Many clients refuse to install software that they don't know.
As a portable application, well, I think that's somehow possible, because you don't actually have to install anything. So if you prepare these, how can I say it? You don't actually install anything on the file system. You don't have an installer for any of those. It's just a set of files, so it can somehow be considered as already portable if you want. Mm-hmm. But you then actually have to run it. So of course you have to provide a path maybe to the configuration files or something like that. So I think you can actually do it as something portable, but maybe that's also up to how much settings you want to set. So for example, if you are logging to a file, it might not be that easy to make that path portable, but that's up how you manage all those settings.
Okay. So how are you doing here with your demo?
The demo is done. I finished it. I will just switch back to the slides for just some quick notes. Sure. So here you have some useful resources, because if you want to set it up yourself, of course, you need to know something more that I just told you. So here you have all the introduction to Telegraf, InfluxDB, and Grafana. So you have all the instruction to install and configure it. You have the plugin list for Telegraf if you want to filter it and check if there is something you can use. Then about Grafana, there are 2 nice websites. One is Grafana Dashboard, which allows you to have a look at the community-made dashboard. Not every dashboard runs, of course, or some are really old, but it might be useful just to have some inspiration. If you see a chart you really like, you can just download the dashboard and see what the chart looks like, and maybe replicate the query on your environment. And the same is valid for the Grafana Playground, which is an instance of Grafana in which you can actually have a look at the features. It's a showcase of the feature of Grafana, but you can actually see some really nice samples and features, maybe about how to query InfluxDB and achieve a specific result. And if you need any more information, just have a look at the Influx Data community and the Grafana community. The Influx Data community is about Telegraf, InfluxDB, Chronograph, Capacitor, and also Grafana. And there you can find questions and discussion about the whole stack. And the Grafana community instead is strictly related to Grafana itself, but it also contains some guides about how to achieve some particular maybe visuals or setups. Well, now let's just quickly summarize. Why should you use it? Well, this stack gives you a complete monitoring solution. So you have the data gathering, the database, and you have a really nice front-end tool, which also allows you to actually set permission and define users. It's really easy to set up. In fact, you have a set of more or less standalone executables, and you just need to provide some configuration for them. So it's easy to set up. It's simple to manage because with the exception of Telegraf, maybe, because you will find yourself changing often your Telegraf configuration, it's really simple to manage. Once you set up your InfluxDB instance, that's it. You don't need to actually do anything else. You will hardly change some settings in it. And the same is more valid for Grafana. You will do everything from the graphical interface, and that's it. Of course, all those tools are free open source, so you can contribute, you can propose new features, and you can also edit them if you want to make it behave in some different way. And it's completely multi-platform, so there is no limit on that. And well, that's it. I hope to see some new questions soon about how to set all this stack, how to set up this stack on Windows or whatever other system, and maybe some question about the SQL Server plugin on the Influx Data community, which is something I look almost daily. So I hope to find some new question there. Thanks for having a look at my session.
So Giovanni, I've got one more, which is kind of a bigger question, which is how is the TIG stack? So TIG, for those who don't know, because I didn't and I had to look it up, is Telegraf, Influx, Grafana. How does that stack compare to the ELK stack? And the ELK stack, for those who don't know, is Elasticsearch, Logstash, and Kibana. So how do you know how those two compare?
Not really, because I've never used the ELK stack, so I can't really answer this.
Okay, and then do you know on anything about, is it Nagios? I'm not sure if I'm saying that right.
I've heard of it, but I don't actually know how it works precisely. But I know it's a data gathering tool, or it should be a data gathering tool.